Alright, this is the video for rational functions, the second part. I told you guys you would have a quiz on the video this week. This is the quiz. You need to list all the parts, y-intercept, zeros, vertical asymptote, horizontal asymptotes, slant asymptotes, and holes. You do not have to graph it. So pause it, write down the problem, do the problem, bring it with you to class. I know you're thinking, what kind of a jerk takes so long to post a video if it's going to be a quiz? The kind of jerk that watches too much Star Trek. So sorry. So these ones are going to be a little bit tougher today. First of all, because we're going to deal more with slant asymptotes, and second of all, because I'm going to give you values where it's not easily factorable, like this one right here. So my numerator has 4 terms. I can't factor it by grouping, which means I need to do the possible rational real roots theorem. So I'm going to use positive and negative, all the factors of 12, 1, 2, 3, 4, 6, and 12 over all of the factors of 1, which is just 1. So I have positive and negative 1, 2, 3, 4, 6, and 12. Now I'm going to look at how many possible positive roots I have. Positive roots, I don't have any sign change, so I know I don't have any positive roots. So I'm not going to try any of these positive values. Really, I'm just going to try negative 1, negative 2, negative 3, negative 4, negative 6, and negative 12. Because they have to be negative. There's no possible positive roots. So I'm going to use synthetic division. Just going to start with negative 1. First term comes down, multiply, add them together, multiply, add them together, multiply. And that one works. This is a root, which means one of the factors is x plus 2. This is now a quadratic. It started with x cubed, so now it's a quadratic. I'm going to put the variables back in. I should be able to factor it now. So now I found all the factors of the numerator. So my numerator, x plus 2. Oh, whoops, why did I write 2 right there? This should have been a 1. Negative 1 is a root, so x plus 1 is a factor. X plus 1, x plus 4, x plus 3. Denominator started out as a quadratic. Should be pretty obvious to factor. If not, use the quadratic formula or one of the other ways that we learned to factor. This is my factored function. I'm going to cancel that out. So I have zeros. Should have done the y-intercept first. That's okay. I have zeros of negative 1 and negative 3 from my numerator. Vertical asymptote of x equals negative 2 from my denominator. Horizontal asymptote. Degree on top is higher than degree on bottom, so there is not one, which means I have a slant asymptote. I'm going to use my long division. Divide my first term by my first term. Leaves me with x, and then I multiply it. Everything here gets subtracted. Those cancel out. Leaves me 2x squared plus 11x, and the 12 comes down. So now I'm going to divide my first term by my first term. I don't care about anything else because I'm just looking for a linear equation. So I have x plus 2 for my slant asymptote. Holes come from what canceled out. X plus 4 canceled out, which means negative 4 is going to be the hole. And the y-intercept, which I should have done first, but I didn't. Plug in 0, 0, 0, 0, 12, 0, 0, 8. So 12 over 8, which is 3 over 2. Now I'm going to graph it. 0 is at negative 1 and negative 3. Y-intercept at 3 over 2, which is 1.5. Vertical asymptote at negative 2. Slant asymptote at y equals x plus 2. So I start at 2, go up 1 and over 1, make a dashed line. So it's going to go like that, which means this is going to come here and attach. And this is going to come here, go through my points. Next one, similar problem. What is that, 2? Okay, again, I can't factor this numerator by grouping, so I'm going to do my possible rational real roots. 1, 2, 3, 4, no, 5, 6, 9, and 18 over 1. Changes in sign, I have 1, so I have one possible positive root. Since 1 is the only option, I know I have 1. So I'm going to try my positives. First term comes down and I multiply, multiply, multiply. Feel like that didn't work. Try the next one. Do I have any papers? I'm gonna write on the back of this. Try 2. First one comes down, multiply, multiply, whoops. Did not work. Try the next one. First one comes down, multiply, add them together, multiply. Did not work. Try the next one. First one comes down, multiply, add them, multiply, add them, multiply, and that one did work. So that means that x minus 6 is a factor. I'm gonna put my variables back in because now it's a quadratic. I can factor that. Whoops. That's a 3. So my numerator, x plus 3, x plus 1, x minus 6. Denominator, going back to the problem that I started with, which is this. No, which is this. Easy to factor out, it's difference of 2 squares. Cancel those 2 out. Do my y-intercept. It's gonna give me, where's the original problem? It's gonna give me negative 18 over negative 1, which is 18. Zeros come from my numerator, which are gonna be negative 3 and 6. Vertical asymptotes come from my denominator, which is going to be x equals 1. Horizontal asymptotes, the degree on top is higher than the degree on bottom, so there's not going to be 1. Slant asymptote, got to divide it using long division. Divide this by this and multiply it down. Subtract these. Those cancel. These are not like terms. The negative 2x squared just comes down. Negative 21 plus 1 is negative 20. And then negative 18 comes down. Divide this by this. I don't care about anything else. So my slant asymptote is y equals x minus 2. Wholes from what canceled out, which is going to be negative 1. So it was 0 at negative 3, at 6. y-intercept at 18. Slant asymptote has a y-intercept of -2, slope of 1. Vertical asymptote at x equals 1. So this is gonna have to go like this. And this one's gonna have to go like this. And that's it. Super easy. Sorry it took me so long.